All right, let's do this. Oh, very different. Oh, you know what? I need to plug in my computer. All right, focus. Emily, get your Chromebook out. Get your notes out. Get the talky stuff off your fingies. Why is this not working? Oh, good, my computer's frozen. All right, so let's do this problem. Let's figure it out. Write the following quotient in simplest form. So we're going to start breaking down these radicals. Well, one of them can be broken down, and this 5 is just 5, right? We can't break that down. There's only the factors are 1 and 5. We can't do that. Did I hit record? Okay, good. All right, so we're going to break down the 640 and the 5, and I'm also going to rewrite this as a big square root, so they're all in the square root home together, so that when I break them down into factors, within the square root home, I can cancel out any matching prime factors. So let's do a factor tree for 640. I can start with 64 and 10, and then I can break 64 down into 8 times 8, right? And I can break 8s down into 4 times 2, 4 times 2, and I can break the 4s down into 2 and 2, 2 and 2. So I have 1, 2, 3, 4, 5, 6 2s there. Break down the 10 into 2 times 5, and those are prime as well. So I've got a 5 in my denominator, because that can't be broken down anymore. And then I have 1, 2, 3, 4, 5, 6, 7 2s. So that's 2 to the 7th power times 5. I could write out all the 2s, but I'm already seeing ahead that I'm not going to be able to cancel out any 2s in the numerator because there are no 2s in the denominator. So I just wrote it with an exponent to keep it nice and simple. So now I have 5 over 5 that can be canceled out. And so what's in my denominator now?
5, 0, 1.
1. So if there's only a 1 in the denominator, do I need to write this as a fraction anymore, or can it be a whole number? Yeah, so I still have it in the radical sign, right? So I have radical, or the square root of 2 to the 7th power. Can I break that down?
Yes.
Can I simplify that? I absolutely can. How should I break up 2 to the 7th power so that I can simplify it?
2 to the 6th power.
Yes. 2 to the 6th power times 2. So I'm basically taking 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. And I'm going to group these together as 2 to the 6th and keep this extra 2 on the side, because my 2 to the 6th, my even exponent, I can set that up as 2 to the 6 over 2, which will allow me to divide 6 by 2 to get 3, and that is 2 to the 3rd power freed from the radical cage. Then I still have this 2 in the radical cage, so I have this got freed by putting 6 over 2. And now I have 2 cubed, which is what? 8.
Oh, sorry.
It's okay. 8 times radical 2. That's my final answer. Let's make sure that's right. I never know if I make a silly mistake along the way. Sometimes counting up your prime factors can be a little tricky. 8 radical 2. Let's hope that that's it. So I don't give you guys the wrong answer. Did you guys have the same numbers or different numbers?
Same.
Yay! We did it.
you already get 100 on
Of course he did. He's a genius. Solution. He is the solution.
Who's the other person that got 100%?
A lot of people got 100%. Oh,
No, it's fine.
Who gets the highest scores from your test?
yeah. Solution.
Doesn't Lucian get 100 on like all the tests?
Pretty much. But amazingly, he still takes notes, he pays attention. He does not all act like, oh, I could just ace this anyway, I don't have to do his work. He does all of his work. He takes great notes, he pays attention, and he takes everything seriously. So I'm less impressed by the straight 100s than I am by the hard work. He's not just a super smart guy. He's also a really hard worker, and that's what impresses me. All right, so we have this crazy situation over here. Write the following product in simplest form. Oh my goodness, they're both in their own little cube root houses. How sweet. This guy's like, hey, you want to come over to my cube root home? And he's like, sure, I'm in a cube root anyway, so why not, I might as well go to your cube root. We can be roomies. We can be cube root roomies. Cube root roomies. So that's 16 times negative 48. And the reason I'm making them roomies is so that when we break them down into their prime factors, we can join all of those factors together and hopefully free some of them from their radical cage. So I'm going to break 16 down into 4 times 4 and then 2 times 2, 2 times 2, done. I'm going to break negative 48. The first thing I'm going to break it down into is what? We did something very similar with a problem on the example in the lesson yesterday. What did we do when we had a negative 75 that we had to break down yesterday? What was the very first thing we did? Emily A., do you have your notebook out? Yeah, what did I do to the negative 75? What was the first thing I broke it down into? Very good. So instead of breaking down the number into 2 smaller factors, I broke it down into 2 factors that would simply pull out the negative as its own factor. So for negative 48, I'll do negative 1 times 48. That allows me to pull out the negative 1 and also take a positive 48 and factor it out. So 48 can be broken down into what? 12 times 4, 4 times 3, circle the 3, 2 times 2, circle the 2's, and then again with the 2 times 2, circling the 2's, and we get, altogether we have 2 times 2, let's count up our 2's. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to write 2 to the 8th power. Now, the only other thing I have is a 3, right? So I have times 3. And then I also have this negative 1. So I'm going to write times negative 1. Now, I'm going to, this step isn't 100% necessary, but I like to do it to show that now, I know they were like cubed root roomies for a little while, but now they're all going to get their own place. They're all going to get their own cubed root home. So we can simplify them individually. Emily, you seem really distracted today, so either you need to shape up right now, or you can sit there. Okay, so the next time I talk to you, you're moving, okay? All right, so breaking them up and getting their own little places on cubed root avenue, we're gonna be able to, oh, you know what? This 8 over 3 is not gonna divide nicely. What should I do? What should I break the 2 to the 8th up into?
2 2 to the 7 times
The 7 over 3 is not gonna divide nicely though.
2 to the 6
Yes.
times 2 to the 2.
Yeah, because 6 plus 2 is 8. So I broke them down so that I can use this 2 to the 6 over 3. And that is 2 squared. So it's freed from the radical cage. So far I've got a 2 squared on my non-radical side. And this will be my radical side, okay? So that part's done. And then what's left in my radical cage is a 2 squared. So I'm just gonna open this up and write 2 squared. And then my cubed root of 3. Can I simplify that at all?
Yeah. An extra 3, 1/2.
I can't just put a 3.
Oh.
It would be 3 to the 1/3, which is the same as the cubed root of 3. So there's really no other way to simplify this, so this is gonna stay in its radical cage, despite all of its rage. Despite all my rage, I'm still in my radical cage. All right, so, oops, I forgot to put my cubed root here. Cubed root of 2 squared times 3. And then here's my -1 that's in my cubey root situation. Now, what number, when multiplied times itself 3 times, will give me -1?
What?
What number, if I'm trying to find the cubed root of -1, what?
1 and -1.
But then it's got to be the same number multiplied times itself. So this number times itself again to get -1.
-1.
-1 times -1 times -1 will get positive and then negative, so it'll be a -1, right? So the cubed root of -1 is simply -1, and that is freed from its radical cage. So does it go outside of the radical or inside of the radical cage? What's that?
Outside.
Outside, good. So we have to multiply this times a -1. And now we just simplify. We've got 2 squared, which is 4, times a -1, which is -4. By the way, this exact question, I was working on it at home on Friday while my son was sick, and I kept getting the wrong answer and I couldn't figure out why. So I just had to put it away. And I broke it out again on Sunday, and I got it, and I was like, I don't know, I was making some silly mistake along the way. I kept ending up with a -8 instead of a -4. But anyway, so I have 2 squared, which is 4, times 3 is 12. That's what we end up with. To make things a little bit easier for you, the question that I chose on the quiz that represents this concept, I didn't include a negative number. It's just positives.
Wrong.
It's saying it's wrong?
Yeah.
-4 radical. Oh, I'm sorry. I forgot to put cube root. -4. I keep forgetting to put my index. -4 times the cube root of 12. Is it right? Okay. 3 more. Oh, I love this one. It's so easy. So easy. You know why? Why is this one so easy?
Because it's only 2 things.
So you can add that.
You can add what? I gotta figure out if these are called anything. Because like I want to be able to say the radicals versus the non-radicals, rational numbers. I don't know. Coefficient? I don't know. So the numbers 5 and 8 can simply be added. And the radicals, since they are the same radicals, it's kind of like when you have common denominators and you just keep the denominator and you do the operation to the numerators, you can kind of think of it the same way. For example, this isn't a fraction problem, but let's pretend it was fractions with common denominators, okay? Let's just pretend. Forget the radicals, just pretend that these are the numerators and 7 is the denominator. If you have the same denominator and you're adding or subtracting, you keep the same denominator and you add your numerators. You're going to do the exact same thing here. You keep the same radical and you just add your non-radicals. So this is just showing you that it's similar.
That's it.
That's it. All right, so this is radical 2 plus 6 over radical 2. Now the trouble with this situation is we're not allowed to have radicals in the denominator. So that's the first thing we're going to take care of. We're going to change this guy to be a fraction that doesn't have radical 2 in the denominator. It can have a denominator, it just can't have a radical in the denominator. What's the only way to multiply a radical times something to free it from its radical cage? Yes?
So we put radical 2 in the bottom.
Yeah, we multiply the denominator times itself, right? So if we do radical 2 times radical 2, that's radical 2 squared, right? So the square root of 2 squared, isn't that 2 to the 2 over 2 power? Isn't that 2 to the 1 power? Isn't that 2? Freedom. Freedom, freedom, get what you take. Something like that. There are so many songs for this lesson, I can't even contain it. Okay, so this is just a very long explanation of showing that a radical times itself will simply be the number broken free from its radical cage, and that's exactly what we want. If we did multiply times radical 2 in the denominator, what do we have to do to the numerator, Emily A?
What?
If we multiply by radical 2 in the denominator, what do we have to do to the numerator? Same thing. Because we're only allowed to multiply by something if we're multiplying by 1. Because multiplying by 1 doesn't change anything. So 6 times radical 2 is 6 radical 2. And you actually can simplify this a little bit. What can we simplify? Nope.
Oh, the fraction.
Yeah, the 6 over 2, right? What's 6 over 2? 3. So cancel, that becomes a 3. Cancel, that becomes a 1. So what is this? It's 3 over 1, but do I need that denominator anymore if it turned into a 1? So I have 3 radical 2 is my conversion. So 6 over radical 2 changed into 3 radical 2. And now I'm going to add radical 2 plus 3 radical 2. Now, this is a little weird because you're like, well, in that last one, we just added the numbers that were outside of the radicals. We added our little free birds, right? This doesn't have a free bird. So what is it? 1. Because this is being multiplied times 1 because everything is being multiplied times 1. This eraser is being multiplied times 1 right now. You just can't see it because the multiplication times 1 is invisible. This is being multiplied times 3 because it has a 3 there. This didn't have a number there, which meant it was an invisible 1. So what's the answer? 4 radical 2. 1 plus 3 is 4, radical 2. This is a little complicated. All right. So the first thing that we're seeing here is that, again, we have a radical in the denominator, which we are not allowed to have, right? So how do we free this radical 5 from its radical cage? Yeah. So we're going to multiply by radical 5 over radical 5 to free this from its radical cage, and now we get 9 times radical 5 over 5. Can we reduce this? We were able to reduce the last one. We did 6 divided by 3 is 2. No, we can't. So this is actually going to stay like it is. There's nothing wrong with it though, because there's no radical in the denominator, so it's totally fine. So this is going to change into 9 times radical 5 over 5. Now, radical 20 needs a denominator of 5, right? Radical 20, in order to subtract these, in order to subtract 9 radical 5 over 5 minus this, I also need a denominator of 5. So I can subtract the numerators, right? So let's give radical 20 over 1 a denominator of 5. Times 5 is 5, times 5 is 5 radical 20. Can I simplify this?
Yes.
Of course I can, but do I want to?
Yes.
No, because if I simplify it, I'll be back to radical 20 over 1, and that's the thing I was trying to change. So I just wanted you to notice that we can simplify, but that was the whole point. It was simple. We expanded this fraction to get a denominator of 5. So we actually want it to stay like that. So now I have 9 radical 5 over 5 minus 5 radical 20 over 5. So we have the same denominator. Now we just have to subtract these. But can I subtract them if I don't have the same radical? No, I cannot. Let's see if we can break down 20. So I have 5 radical 20. I'm taking this numerator, and I'm going to see if I can break it down to pull out some possibly perfect squares. So now we have 5 times the square root of 2 squared times the square root of 5. What can I simplify? Anything I can simplify? Anything that can be freed from its radical cage?
Yes.
Yes, what is it?
Oh, sorry, the 2.
Yep, the 2. Because this is 2 to the 2 over 2, that's 2 to the 1, that's 2. So this is free now. 2 is no longer in its radical cage, and it is going to join the 5. So it's going to be 5 times 2 times the square root of radical 5. And take a look. We converted this to this. So I'm going to continue writing that down here. 9 radical 5 over 5 minus 5 times 2 is 10 times radical 5 over 5. Because remember, we were taking this 5 times radical 20 to turn it into 10 times radical 5. We freed those jailbirds. So we're going to minus 10 radical 5 over 5. Now we have the same denominators, so our denominator is 5. And in the numerators, our radical is the same, so we can subtract the numbers. What do we do? Subtract what? Yep. What do we get? Nope. -1. So we have -1 times radical 5 over 5. Now, if you put it exactly like that into, I'm actually curious, I'm gonna write that. I wanna see if it will accept this answer, because really you should simplify it to be a negative radical 5 over 5, negative radical 5 over 5, which is simply a negative radical 5 over 5. So this is the exact answer you want. I'm so curious to see if it would accept this answer. So I'm going to put this one. -1. Wait, I got to put in fraction. Fraction. I'm going to do -1, and then I'm going to do radical 5. Don't do what I'm doing right now. I'm just seeing if it's going to accept this. I'm just curious to see if it would accept this if you guys did. Okay, I'm going to put that in and check. Oh, it accepted it. That's really good news. That makes me happy that it's not going to be super picky about the way you write it. And that's it, guys. That's the homework.